let's look at two examples of some genes now and use the pedigree to prove if they're dominant or recessive. So our first trait is tongue rolling. For this example, we know it's dominant already, but in the future, you won't know, and that's the whole point of these questions. You'll need to figure out if it's dominant or recessive. So because it's dominant, let's say the alleles for tongue rolling are big R and small r. And because we know it's dominant already, we know that the big R must be the rolling allele, people who can roll their tongue, and small r is the no rolling, people who can't roll their tongue. So let's look at this pedigree here. This is one small family. We've got generation 1 and generation 2. And in generation 1, we've got individual number 1, and she's the mum. Individual number 2, he's the dad. And then they've had 2 children. They've had a boy, person 3, and they've had a daughter, person 4. So looking at the shading, we can see that both parents can roll their tongue. They have this trait. And their son has the tongue rolling trait too, but the daughter doesn't. So the question is, can we use this to prove if tongue rolling is dominant or not? Well, one strategy we can use is to try and figure out the genotype of each person in the family. So the daughter here, if she doesn't have the tongue rolling trait, she must have small r, because that's the only way to show that phenotype, that trait. So that means if we think about the Punnett square for this family, if the daughter had small r, the daughter is small r, then she must have got one of those R alleles from her mum and one from the dad. So let's say we've got mother and father. So let's keep working backwards then. But we also know that the father, he can tongue roll. So he has the trait. So that means he must have a capital R allele too, because that will make him, if we write out his genotype, that will make him, capital R, small r. So his genotype is he can roll his tongue. The mum, she's exactly the same. She must have one small r allele and one big R allele, because that's the only way that she can roll her tongue, but still have a daughter who can't roll her tongue. And then we can work backwards and fill out the rest of the Punnett square for this family. Capital R, small r. Okay, so we can see here's the daughter represented here. The son, he has the tongue rolling trait, the phenotype, but we're not sure what his genotype is. So let's fill out the dad and the mum. So if we look down at the Punnett square, each one of the other 3 possibilities, they all have the tongue rolling phenotype. So we're not sure what the son's genotype is. So the mother must be the same. The daughter has small r, so she's homozygous. The father and the mother are heterozygous. But the son, we're not sure. So we can write he could either be homozygous dominant, 2 copies of the capital R, or he could be heterozygous dominant. But either way, he is going to be able to roll his tongue because we knew that on the family tree. So the one way to prove if a gene is dominant, if a trait is dominant, is if two parents have that trait and they have an unaffected child. So we can prove it. Two affected parents can have an affected child. Let's move all this down for now. And we can prove that because if this trait was recessive, that would mean that the father and the mother both have the trait. So they would have to be small r for both of them. And then, if we think about that Punnett square, then if both the parents are homozygous for small r, then all their children have to be small r. There's no other possibility. So if we see this information in a pedigree, we can prove that a trait is dominant. Okay, let's move on to recessive traits now. How can we figure out and prove that a trait is recessive? Well, let's use the widow's peak as the trait for this one. And we've got Thor with his widow's peak. Well, Hemsworth, whatever his name is, Chris Hemsworth. So let's just say that widow's peak is recessive. Remember, a widow's peak is the point in the middle of your hairline at the top of your forehead. So if widow's peak is recessive, we will use capital W and small w, but in this case the small w represents the allele for widow's peak, and a capital W is just a straight hairline. Alright, so here we have a family tree. It's a similar family. Well, it's actually the same one. We've got two parents and a son and a daughter. So let's label the generations and the individuals. But now we've got neither of the parents have a widow's peak, but the daughter does. So let's use some deduction with our Punnett square again. If the daughter does have a widow's peak, that means she must be small w, which means both of the parents must have given her a small w. But they have a straight peak themselves. So let's make this the mother and the father again. So the mother, she must have one small w, but she must have a capital W to have a straight hair, and the same for the father. So we can fill in the rest of the Punnett square. Capital and capital, capital and small w. So the daughter, we can prove for sure, she has to be homozygous recessive. She has widow's peak as the trait. And the mother and the father, they are both heterozygous because we know they both have to be carrying one of those small W alleles. We call them a carrier. Mother and the father, heterozygous, so they have straight hairline. And the son, similar to last time, he could be homozygous or he could be heterozygous. All we know is that he has straight hair, a straight hairline. So he could have big W, small w, or two big W's. But he definitely has a straight hairline. So that shows that widow's peak is recessive, and the overall summary to look for in a recessive trait is that two parents that aren't affected, they can have an affected child. And that's what proves that a trait's recessive. Two parents unaffected can have an affected child. Well, let's figure out, lastly, how we know that it's not dominant. So if this widow's peak was dominant, and we had two parents that are unaffected, then there's no way they could have an affected child. So let's go back to the dominant situation earlier. We had rolling of the tongue. So capital R was rolling and small r was no rolling. If we're looking at the tongue rolling situation here, and this is the family tree, if the daughter is affected, she could be big R, little r, or big R, because we know she can roll her tongue. But if we think about the Punnett square now, she could be big R, little r, or big R. Well, that means that she must have got a big R allele from either, let's say the father is here and the mother is here. If she has the trait, then that capital R must have come from the father or the mother. So the mother or the father must have a big R. But if they had a big R, because tongue rolling is dominant, then they would also be affected. They'd have the tongue rolling trait. So in a dominant trait, there's no way that two unaffected parents can have an affected child. So that's how we prove if a trait is recessive. So we need to remember these two rules. For dominant traits, two affected parents, they can have an affected child. And for recessive traits, two unaffected parents can have an affected child.